Hello everyone and welcome to our pre-calculus class. We're going to start off with a lesson about quantities that are changing together. Change is all around us. We grow older and we grow taller. We can measure these changes, and we can also measure and compare two quantities that are changing at the same time. For instance, how tall you are as you grow older. We might see a graph like this if we were to record your height at various ages. Now in this course, we often analyze two quantities that are changing and compare them using a graph, table, or equation similar to the example we just did. We're going to be focused on a Ferris wheel in this lesson because it helps us demonstrate a lot of key concepts later on in this unit. If you'd like to follow along with this investigation, please view the GeoGebra file that I've had linked in the description. Let's select one of the seats on the Ferris wheel and watch it as it revolves. The distance that the seat travels around the wheel is one quantity that is changing. The height of the seat is another quantity that changes. To simplify our picture and graph the rider's height as they travel around the Ferris wheel, we can imagine a dot going around a circle and then graph that on an XY coordinate plane. In this graph, the x-axis represents the distance that the rider has traveled, and the y-axis represents the height of the rider. Let's analyze the relationship between the two quantities. The distance traveled is always increasing because we're going around and around the Ferris wheel. The height, however, increases at first as the rider goes from the bottom to the top, and then decreases as the rider goes from the top to the bottom. Let's identify some key characteristics of this graph. The y-intercept is at 0, 2 because before the rider moves at all, they are 2 units above the ground. There are no x-intercepts because the rider never touches the ground, or in this case, never touches the x-axis of our graph. The maximum occurs after the rider has traveled a little bit more than 12 units and is 10 units above the ground. There are two minimums. One is the y-intercept, and the other occurs after the rider has made a full rotation around the Ferris wheel. Finally, let's zoom in on the first half of our graph. The graph is increasing here, but not always at the same rate. Let's compare how much the graph increases over different intervals. Here, if we go over 1 unit, the graph is only increasing by a little. Move over another unit and the graph increases more. The pattern continues as we move further along the graph. The rate of change is increasing here, so we say that the graph is concave up. Move further along, however, and here the graph is increasing less and less each time we move over 1 unit. The rate of change is decreasing here, so we say that the graph is concave down. We can observe similar behavior further along the original graph as well. The graph here is decreasing, but not at the same rate. This section is concave down. Here we're decreasing less or increasing, so the region is concave up. Thank you. We hope this video is helpful and that you visit us again.